topic that we are sharing today, as seen from the title, it is indices and surds. So I've prepared 3 questions to cover types of question that might come up from the indices topic, and another 4 questions to cover the surds. So before we get into the examples, there's a few things that I have to go through with you first. Okay, the first thing is the index law. So before you start, you must be able to differentiate what's the base, what's the power. Okay, so it's kind of related to the previous topic I covered, which is logarithm. So the concept from here will lay out as a foundation for logarithm. So the first law that I'm going through is that, as you can see here, a to the power of x times a to the power of y, since their base is the same and the relationship between the variables is multiplication, all you need to do is to add up their respective power. So you have a to the power of x plus y. Moving on, we have division here. Since the base is the same, so you must minus them off. So divide here can also be interpreted as a to the power of x at the numerator and a to the power of y at the denominator. So when you bring up the y, it will automatically put a negative at the front. You can also treat this as a to the power of x multiplied with a to the power of negative y. Moving on, we have a to the power of x itself, and then you have a bracket, another power of y. So if this is the case, x and y's variables relationship here is multiplication. So you have a to the power of x times y, or xy. If you have more than one variables inside the bracket, the x is actually applied to both of them. So you have a to the power of x and b to the power of x. Same goes to fraction form. Then you have a to the power of x divided by b to the power of x. You can also write this as a to the power of x multiplied with b to the power of negative x. Moving on, this is the part that I have going through twice. So we have 1 being divided by a to the power of x. When you bring up the a to the power of x, you're required to add a negative at the power section. So this 1 over a to the power of x can be interpreted as a to the power of negative x. So b to the power of y divided by a to the power of x, this one can be written as b to the power of y times a to the power of negative x. And if their base is the same, like the one that we have earlier, so the relationship divide will become minus at the power section. So a to the power of y minus x. Last but not least, okay, if you have a negative at the denominator, when you bring it out, okay, if you have to add a negative to represent the division. So the negative multiplied with the negative x, then it becomes plus. So since their base is the same, combine the power together, you have a to the power of y plus x as your final results. Another important thing here is that anything to the power of 0, it will automatically be 1. It doesn't matter what the base number is. As long as the power is 0, then it's automatically linked back to 1. Another thing here is when it comes to square root means that the roots has a power of 2. So when we write it into indices format, square root can be interpreted as to the power of 1 over 2. So if you have something like cube root, then it is 1 over 3. Or your a now inside the square root or whatever root that they gave you actually have power now. And the power that is from the value inside the roots will be placed at the numerator part of the power. So we will have a to the power of x over y. Alternatively, if your power is actually outside of the root, okay, it's actually the same because the fundamentals never change. A to the root of y can be written as a to the power of 1 over y, then the power being multiplied with the x. So it becomes a to the power of x over y. Last but not least, this is the most important one and you have to really practice to get good at it, is this red box over here. So we have 6x squared bracket to the power of 3. The power of 3 is to be multiplied into everything inside the bracket. And sometimes the question will ask you to further break down the numbers value over there. Like 6 over here, I can break it down into 3 times 2. Or if it's 12, I can break it down into 6 times 2, 4 times 3, or other possible combination. So you have to look up to all the variables inside the question and determine which combination for you to use. Okay, so this is just a brief example. Later on when we go through the question, we have more in-depth explanation on this. So the power of 3, let's say I broke down my 6 into 3 and 2, right? So the power of 3 will then be multiplied into each of them. So my final results from this is actually 3 to the power of 3 times 2 to the power of 3 and x to the power of 6. Aside from this, we have to go through the Surds call formula as well. In Surds topic, it always surrounds this formula that we learned in our algebra, which is a squared minus b squared equals to a plus b, a minus b. So this particular concept is being used when you have a denominator and it has surds inside of it. So let's look at this 1 over square root of a plus b. So in order for you to get rid of these surds, we must adopt the formula that we learned in our algebra, which is the one that I showed you earlier. The relationship between the variables is plus. In order to cancel off the surds, I will put in a minus 1 next to it. So I multiply the numerator and denominator with square root a minus b. So at the bottom part, you can look at the denominator now. When these two variables being multiplied together, then you will get a squared minus b squared. So our a here is actually square root a. Square root a squared, then you automatically get rid of the square root already. So you have your denominator results as a minus b squared. As for the numerator, the 1 multiply into square root a and negative b, then you get square root a minus b. So the 1 you multiply with square root a minus b, so nothing changed. So the final result is square root a minus b over a minus b squared. Next to it, I also show another example. This is when the question gave you the relationship between the variables as minus at the start. So what you need to do is to multiply a addition 1 next to it. So I won't go through this because they are very similar. You can look at it and figure it out. Moving on, we have another example with square root at the numerator part. So let's look at the bottom first as per usual. The denominator side, we have the variables minusing off each other, which means they have to multiply a plus square root b into both numerator and denominator. By doing so, you will get your final denominator results as a squared minus b. the b square root was being cancelled, okay, during the square process. Another part that students struggle to answer here is, remember to always take the a, multiply with a, followed by a multiplied with square root b, then move on to the positive square root b multiplied with a, and square root b multiplied with square root b. So I listed down all the details over there. Your final result should be as a squared plus 2a square root b plus b over a squared minus b. So this is the details. Okay, you can copy it down. If you feel like getting the slides, it's available in the link below. So all this additional mathematics video that I make, there's always the free slides available at the description. Moving on, we have when the surds multiply with each other. So things to take note is, as long as their value on the root is the same, the variables inside will be multiplied to each other. So we have square root a multiplied with square root b. It will automatically be translated as square root of ab. So we have square root 8 times square root 27 should actually get 216. So 216 can actually be broken down into 36 times 6. 36 is actually 6 squared. By having this 36 over here, I can finalize my results as 6 square root 6. If it's divide, it's also the same thing. Put it under the square root, so you have a over b inside of it. So I have square root 8 divided by square root 54. I gotten square root 4 over 27. I break down the 4 and 27 into 2 times 2 and 9 times 3. And then I gotten 2 over 3 square root 3. Remember that I mentioned you cannot have surds in the denominator. So these are the special types where it didn't plus with anything or minus with anything. So all you need to do is to multiply another square root 3 into the numerator and denominator. Then you can get your denominator as 9 and you have a numerator of 2 square root 3. The process of getting rid of the surds inside the denominator section, this is actually called rationalizing the surds. It may sound a little bit vague, but it is very crucial when it comes to this type of question. So you have the red box at the top right corner. That's the rules that apply to surds condition where it has a root at the denominator. So for indices, there's a few topics that they always try to associate this with. Will be simultaneous equation, substitution and factorization, and comparison. So all this is covered in your example later on. As for surds, they always incorporate it with shapes like triangles and stuff. So your cosine rule is very important, your area calculation, as well as your ability to rationalize on the denominator section. So let's go through our first example here. So to make this possible, you need to make your arrangement step by step. So the first thing, I took 3 over 2, multiply into all the variables inside the bracket. So when you see like p, this single variables here, they didn't mention about the power, right? When they didn't mention about anything, means that the power of it is 1. So multiply the 3 over 2 into it, and you will get p to the power of 3 over 2. As for next variables, next to it, we have r squared multiplied with 3 over 2. So you will get r to the power of 3 because the 2 and 2 cancel off. So the square root there can be changed into 1 over 2. Multiply the power in, then you will get q to the power of 1 over 2 and r to the power of 1 over 2. Moving on to the denominator, q squared, there's no other arrangement for it, so I just leave it as it is. Then I multiply the negative 1 into both of the variables inside. Then I get p to the power of negative 1 and r to the power of negative 2. So now I try to link up. I color coded them, like p with p, r with r, and q. So the first thing that I arranged was to try to shift up the negative 1 back into the numerator side as a whole number. So the process of doing it will add a negative at the front. So p to the power of 3 over 2 minus negative 1. So we will get p to the power of 5 over 2 as your final results. Moving on to q, I have 1 over 2 at the numerator and I have 2 at the denominator. Shifting it up, we'll put a negative in the power. So I have q to the power of 1 over 2 minus 2. And the last part here, we have r. After arranging the variables at the top, I have r to the power of 3 plus 1 over 2 minus negative 2 because I brought up the results from denominator to the numerator. So after the calculation, you will get your r as 11 over 2 and your q is negative 3 over 2. So that's your A, B, and C's value. The next example here is simultaneous equation, and I adopted the substitution method. So I arranged everything from equation 1 and I gotten when y to the power of negative 1 over 2, it will get me 3x to the power of 1 over 2 minus 4. Substitute this equation 3 into 2. And after I run the calculation, I get 4x to the power of 1 over 2 plus 9x to the power of 1 over 2 minus 12 equals to 14. Further rearrange them and I gotten x to the power of 1 over 2 equals to 26 over 13. So remember, the question is asking you for x only. However, you have a 1 over 2 in the power section. In order to get rid of it, my power should be transformed back into 1. So I decided to square on both sides. So I multiply 2 into them. Then I get x to the power of 1 over 2 bracket square equals to 2 square. So my final answer, x will be 4. Substitute x equals to 4 into equation 3 to identify our y here. So 3 bracket 4 to the power of 1 over 2 minus 4 equals to y to the power of negative 1 over 2. After the arrangement, I gotten 2 equals to y to the power of negative 1 over 2. So our power now has a negative involvement. So only when negative multiply with negative, I get back into positive. And we have a denominator of 2, so I decided to multiply the power of negative 2 into both sides. So I automatically cancel it off and I gotten y equals to 1 over 4. The process itself wasn't really complicated. The key things lies on whether you can multiply the correct power into the variables. So you need more practice on this. You can search out your past years and pick up a few questions and run some practice on this. Moving on to example 2, we have 7 to the power of x times 49 to the power of y equals to 1, and 5 to the power of 5x times 125 to the power of 2y over 3 equals to 1 over 25. So this 2 is actually a separate equation. I arrange from the 7 square times 49y equals to 1 first. The 49 can actually be transformed into 7 square. So the 7 square multiplied with y, then I will get 7 to the power of 2y. So since the base is the same, I arrange them into plus. So I have 7 to the power of x plus 2y equals to 1. So the 1 over there actually play a crucial role. You're required to transform the 1 Based on the rules earlier, anything to the power of 0 is 1, but I won't put any numbers. I will select 7 only because I wanted their base to be the same. So only when their base is the same, like 7 to the power of 0, then I can extract the power of x plus 2y equals to 0 and treat it as my equation. So moving on to the following equation, we have 5 to the power of 5x times 125 to the power of 2y over 3 equals to 1 over 25. So the things that I need to change here is the 125 and 1 over 25 at the other side. So 125 can be transformed into 5 to the power of 3, and 1 over 25 can be changed into 1 over 5 squared. So the 5 squared can be bring up to the numerator by adding a negative into its power, and the numerator of 3 and the denominator of 3 will automatically cancel out. So now that I have all the base as the same, I can write it as 5 to the power of 5x plus 2y equals to 5 to the power of negative 2. Extract the power section, then I got my second equation as 5x plus 2y equals to negative 2. So from 1 itself, you have the equation 3 as x equals to negative 2y. Substitute this into equation 2, then you will get negative 10y plus 2y equals to negative 2. Then you have your final result of y equals to 1 over 4. Substitute this 1 over 4 into your 3, then you get your x result as negative 1 over 2. Moving on to example 3 here. Okay, so we have 6 to the power of p times 8 to the power of p plus 2 times 3 to the power of q. It was being divided by 9 to the power of 2q minus 3. And this entire thing is equals to 2 to the power of 7 times 3 to the power of 4. So this is the part where you need to practice how do you break down the numbers into the correct combination. The equation after the equal play a crucial role. So you're required to break down whatever numbers that was at the front into 2 times 3's combination. So 6 can be treated as 2 times 3 bracket to the power of p, and my 8 can be changed into 2 to the power of 3 bracket to the power of p plus 2. As for the 3q, I just leave it because there's no special arrangement for it. As for the denominator, 9 can be changed into 3 to the power of 2. So now I multiply all the powers into the variables that I have there. Then we have 2p times 3p times 2 to the power of 3p plus 6 times 3q. As for the denominator, I have 3 to the power of 4q minus 6. I arrange them and change it into 2 to the power of p plus 3p plus 6 times 3 to the power of p plus q. As for the denominator, there's no changes for me to do. All I need to do is to shift it up. So I put a negative bracket 4q minus 6. So you run the calculation, you will get 2 to the power of 4p plus 6 times 3 to the power of p minus 3q plus 6. And this is being compared to 2 to the power of 7 times 3 to the power of 4. So I color coded them so that I can run the calculation more effectively. So I have 4p plus 6 equals to 7 and p minus 3q plus 6 equals to 4. After you run the calculation, you should get your p as 1 over 4, and by substituting 1 over 4 into the red color equation over there, you will get your q's final results as 3 over 4. As for next part, using the substitution, so we have u equals to x to the power of 1 over 3. So all the x to the power of 1 over 3 in the equation must be changed into u. So after going through the question, I only identified one x to the power of 1 over 3 only. Means that the x to the power of 2 over 3, there's some adjustment needed to be applied onto it. So I actually changed it into x to the power of 1 over 3 bracket square based on the rules that I learned earlier. I can actually take out the numerator and put it at the brackets. So x to the power of 1 over 3 can be changed into u squared. Now I rearrange it and I have u squared plus 4u plus 3 equals to 0. So for this, we now know that you need to run the factorization process. So I didn't show you the factorization process in details here because I expect you to have some knowledge on it already, because this topic is mainly assessed in your additional mathematics. So you have u equals to -3 and u equals to -1 now. So if you stop here, this is the part where most of the students lose their marks because they didn't work out and get the final value of x. So I change x to the power of 1 over 3 equals to -3. Then I multiply both sides by a power of 3 in order to get to x to the power of 1. So after the calculation, you will get your x as -27. As for u, on the other hand, you will have x equals to -1. So this too will be your final answer. So that's pretty much it for indices topic. Moving on, we have Surds question here. So square root 8 divided by square root 7 minus square root 5. So in the form of square root a plus square root b, where a and b are integers. So immediately I know that they are assessing us on the rationalization on the denominator. So the relationship between the variables was minus, which means I have to multiply both the numerator and denominator with square root 7 plus square root 5. So the denominator, I can arrange it into square root 7 bracket square minus square root 5 bracket square. And the square root of 8 is supposed to be multiplied into both square root 7 and positive square root 5. After the arrangement, I get square root 56 plus square root 40 divided by 7 minus 5. So you have 2 at the bottom. So I change the 56 into 4 times 14. And I change the 40 into 4 times 10. So both I can get rid of a 2 from them. So 2 square root of 40 plus 2 square root of 10 over 2. So since all of them has 2, I can extract it and cancel it off. So your final answer from this should be square root 14 plus square root 10. And your A will be 14, the B will be 10. Moving on, given that 28 plus P square root 3 equals to bracket Q plus 2 square root 3 bracket square. So I first square the q plus 2 square root 3. After the rearrangement, I gotten q squared plus 4q square root 3 plus 12. By doing so, I rearrange it. Those without square root 3, I put it at the front. Those with square root 3, which is 4q square root 3, I put it at the back. So I know that my q squared plus 12 is being compared to 28. And my 4q square root 3 is being compared to p square root 3. So I try to identify what's my q value here first through this equation. Q squared plus 12 equals to 28. Then I gotten q squared as 16. So my q is actually plus minus 4. I then move on, substitute this 4 and negative 4 to identify p. So 4q equals to p here because the square root 3 on both sides cancel off each other. Then I will get p's results as plus minus 16. Moving on to example 2. Okay, the first part involved multiplication of surds, and for the plus 9 square root 30 over square root 15, it's hinting me that I have to rationalize the denominator by multiplying another square root 15 into it. So 24 times 27, I get square root of 648, and after multiplying square root 15 into both of them at the back, numerator and denominator part, I got a 9 square root 450 over 15. So I arranged the 450 into the combination I wanted, which is 225 times 2, and I arranged the 648 into 324 times 2. Reason why I leave a 2 on both of them, because the requirement of the question, they wanted it to be in square root 2. So 322 can be changed into 18 square root 2 plus the one in the back is actually 15 square root 2 times 9. So 15 and 15 will automatically cancel off. So I gotten 18 square root 2 plus 9 square root 2. Add these two up, then you get 27 square root 2. So our A here will be 27. Moving on, solve the equation square root 3 bracket 1 plus x equals to 2x minus 3. Give your answer in the form of b plus c square root 3. So I first multiply the 2 into the bracket and also the square root 3 into the bracket. I arrange all the x to one side, extracted x from it, so I get x bracket 2 minus square root 3 equals to square root 3 plus 6. So I get rid of the 2 minus square root 3, then I got then x equals to square root 3 plus 6 over 2 minus square root 3. However, you have a square root in the denominator, and that is not allowed. So you're required to rationalize it by multiplying a 2 plus square root 3 into both the numerator and denominator. So you get your final results of the denominator as 2 square minus square root 3 square. Multiply the numerator part accordingly, then you will get 15 plus 8 square root 3 as your final results. Your B will be the 15 over there, and your C will be 8 over there. Moving on to example 3, this is the part where area calculation take place. So we have a trapezium that's shown over here, and they gave you the area at the start. So trapezium formulas goes by top plus bottom divided by 2 times x. So I have 3 plus square root 5 plus the bottom is 3 plus square root 5 plus 20. These two add up, divide by 2 times x, and it is equals to 13 plus 5 square root 5. So I rearrange it first before I proceed with the calculation. So I change up the square root 20 into 4 times 5, get rid of the 2 from all of them. So I have 3 plus 2 square root 5 times x equals to 13 plus 5 square root 5. So your x here will be 13 plus 5 square root 5 divided by 3 plus 2 square root 5. So I try to rationalize the denominator by multiplying a 3 minus 2 square root 5 into both of them. So you have a denominator of 3 square minus 2 square root 5 bracket square. So the calculation for that will get you 9 minus 20, and the numerator part you need to multiply them accordingly. 13 times 3, 13 times 2 square root 5, 5 square root 5 times 3, 5 square root 5 times negative 2 square root 5. After the calculation, you will get negative 11 minus 11 square root 5 over negative 11. So all of them has negative 11. So I extracted it and cancel it off. I got my final answer as 1 plus square root 5. So my P here is the 1 and the Q is also 1 as well. It is the indivisible numbers in front of the square root 5 over there. Moving on to the last example that we have here is the incorporation of cosine rules. So in triangle ABC, AC is square root 3 plus 1, BC is square root 3 minus 1, and angle ACB is 60 degrees. Without using a calculator, show the length of AB equals to square root 6. So using cosine rule here, AB squared equals to BC squared plus AC squared minus 2 times BC times AC times cosine ACB. So AB will be square root of the entire thing, multiply them and calculate it accordingly. So the 2 square root 3 will be cancelled off in the process. So my arrangement from the front will get me 8, and I have minus 2 times 3 minus 1 times cosine 60 at the back. After the rearrangement from the last part, I will get 8 minus 4 1 over 2. And that will be able to get the final result as square root 6. And this is how you prove the question. So that's pretty much it for Indices and Surds example. I hope you find it helpful. If you have friends that are struggling, feel free to share this to them. And as mentioned earlier, please do not rely on this video alone. You need more practice for you to nail any kind of question like this. So I wish you all the best in your upcoming examination. Thank you.